new startups, companies that we've never existed before, developing new electric vehicles, as well as what you guys see in the garages and the colleges and stuff like this, and the challenges over those. And I developed a kind of inkling that probably one of the challenges that's probably going to come to the fore is batteries, because they're big, the technology is reasonably new, although they've improved enormously over the last sort of decade and stuff like this. And not only just in battery chemistry, but monitoring and efficiency and all that kind of stuff. But of course, despite all that, and we know in the motor trade, despite the best engineering in the world, we're still going to see failures. We're still going to see problems. And of course, if we're dealing with electric batteries, unlike an engine, when you're mechanically, if someone came to you in your garage or
the idea is if you want to do it, you can do it. We're not forcing everybody to do it, or whoever wants to get involved can do it. Stand back with the idea. I guess if you're not doing many of these, it might be an opportunity for you in a no pressure environment just to sort of dig in, jump in and do what you need to do. We're here to answer your questions, so if you're not sure about anything, if you're wondering why this is happening and should we do this instead, well, that's we're here to answer your questions, and that's what we're here for. So
I believe in repairing or diagnosing and repairing batteries that I want to allude to a little bit. So what I thought we'd do is we're gonna give this Nissan, we have already give this Nissan a problem. We've got a fault in there. I'm going to walk you through that process. And the fault is not necessarily the leading, it's just a fault. There could be a number of faults within the battery system, but this one is just going to show us a fault where we need to have to diagnose it and we need to have to repair it. Okay, not necessarily the actual cell and the module itself, it could be some other problems as well. So I want to cover off as many angles as you possibly can to make sure that we don't make mistakes. You know what it's like, we don't want that vehicle to come back again and again and we misdiagnose it and go, chuck the parts bin it and stuff like this, and we find out that we've not done the job properly. And of course, if we get it wrong, it can get really serious. Really serious. I don't know if you're familiar with battery assemblies, but I've seen it happen where people have connected up two modules, short-circuiting together. Yeah, and it really is, and that's just two modules, and it gets really serious straight away. And and not only is it serious from a safety point of view, but it's a cost point of view, because those cells now, that battery is useless. You can't use it anymore because it just literally blows the terminal off the battery at best, and worse than that. And if it doesn't blow the terminal off, you're going to have a kind of thermal incident, and that can get quite significant at some point. So, and of course, we need to make sure it gets right. So I'm going to kind of walk you through the process as far as. What I want to show you first of all is, I'm not going to worry about all the component locations and stuff like this. What I want to show you is, so we're looking at this battery here. So it's a 360 volt battery. And when we say 360 volts, what do we mean by that? Because it's never said 360, is it? If you go to that vehicle and you look on the data list, whatever state of charge it is, it's going to be whatever it is. If you look at a 12 volt system, it's never 12 volts, is it? You'd be worried if it was 12 volts, wouldn't you? Because you want to see at least, what, 12 and a half, 12.6 as a good healthy battery when it's not being charged or discharged. So when we say 360, we mean the nominal voltage of that battery. And of course, how do we get with that to the battery? So how do we get to 360? Because we're going to put a lot of cells together in series. It's a fairly small battery. It's only the early 24 kilowatt battery. I know we get a lot bigger than that. We're seeing now, what, 60 to 80 kilowatt batteries now, kilowatt hour batteries in the marketplace as products. And we need that as capacity to make sure that consumers are happy with the range and everything else. It's quite a significant weight, over 260 kilos, and we know that it can get heavier than that. So we know that if you take a Tesla battery out, you're looking at nearly just around about 1,000 kilos for that. So it's a significant piece of the vehicle, weight of the vehicle. It always amazes me that you've got 1,000 kilos, you've got a 2-ton car, and they still accelerate pretty much every supercar that you can probably list. Yeah. Well, you get through a lot of times at some point. Now this battery is assembled with 48 modules. I'll show you what one looks like. You can pass it around if you want. So in this module here, we've got 48 modules, and there's 2 cells in series. Okay, so that's why we've got 3 terminals. So you've got a negative, 2 positives. Okay, so the battery management system can see the cell voltage, every individual cell voltage in there. Okay, and there's 2 in parallel in this case. So what's the benefits of having parallel batteries, guys? Any ideas?
If one gets damaged, then you can see this.
No, you're not wrong in thinking that. You've written the right direction. From an engineering or from a designer's point of view,
step by step and work through that. And as Elliot said, the idea is that you get involved physically. So the idea is if you want to do it, you can do. We're not forcing anybody to do it, or whoever wants to get involved can do it. Sort of stand back and guide you. I guess if you're not doing many of these, it might be an opportunity for you in a no pressure environment just to sort of dig in, jump in and do what you need to do. We're here to answer your questions, so if you're not sure about anything, why this is happening and should we do this instead, well, we're here to answer your questions, that's what we're here for. So